project a body not from the ground, from some height, from the tower, from the building. Okay, you are standing on one building which is already having some height h, so you will project a body, so it will go some height, then it will come back where, not on the building, it will come to the ground. Okay, so today we will discuss about the motion parameters for a body projected from a tower. Okay, so what is that? For a body, motion parameters for a body projected from a tower. Okay, means from some height or from the building or whatever. Okay, so we can simply write it as from a tower. Okay, so suppose you are standing on the building. Okay, so suppose you are standing on building, its height is say h. The height of building is what? Height of building is h. This is what your ground. Okay, this is what the ground, and you are standing over here, and you will throw a body in an upward direction. Okay, so when you throw a body here in upward direction, so what will happen? Body will go and it will reach some maximum height, then it will come back not to the building, it will come to the ground. Okay, so for this kind of situation we will see what are the motion parameters. So what are the motion parameters means what? How much height it will reach from the tower or from the ground. Very important is time taken to reach the ground. Okay, first I will go with that only. What is that? Time taken by the body to reach ground. Okay, so to reach ground, not tower, to the surface of earth. Okay, so if this is the case, look at the other parameters properly. Now you are throwing with some velocity, you are given some velocity, that is what u. Okay, u is in this direction, u is in upward direction. Okay, so what about the acceleration? Acceleration is equal to z. Acceleration is equals to g, but you are throwing in upward direction. When you are throwing in upward direction, g is what? G is downward direction. So velocity and g are what? Opposite. So you can take acceleration as, instead of g, you have to take it as minus g. Okay, and this is what we know. Then h we know. What we have to calculate? We want to calculate the time. So if you want to calculate time, you can take use of s equals to ut plus half at square. Okay, normal equation. But here, in this case, s is what? S is the displacement. U is what? U is initial velocity. I will take u as u only from here. What about a? A is what is that? Minus z. Okay, a is minus g. So s is what? S is height. So height we can take it as h. Okay, so s equals to h. Now if you write the equation, what you can write? H equals to ut minus half gt square. Ut minus half gt square. Okay, so this is what. Now one more very important here. H is not a distance, it is what? Displacement, because you are taking u as a velocity. If you are taking as velocity, so h is going to be what? H is going to be a displacement. Then what is the displacement? This is what your initial position. This is what your final position. Okay, then what is the displacement? Displacement is distance between initial and final position. This is what your displacement. What is that? That is nothing but h. But listen here properly. First you are moving in this direction, so whatever distances you will take on this side are what? Positive. Whatever distance you take on this side are going to be negative. Just like if you are moving from the origin, this side you will take positive, so this side you will take what? It is a negative. So similarly, if you are starting in this direction, you are going to take positive, all parameters positive in this direction, all parameters are negative in downward direction. So your displacement is what? If you take this as the reference point, if you take this as the origin, So this is on this side. This side you have taken positive. So this side your displacement is going to be what? It is going to be minus h. Okay. So h, since h is along negative y-axis, so what you have to take? You have to take h as minus h. So right here minus h equals to ut minus half gt square. Okay. Now if you solve this equation, you will get the time. H, you know, height of the tower they will give, velocity, initial velocity u, that they will give you. G you can take 9.8 or sometimes 10. Okay. So all three unknowns are known quantities are there. Only t is unknown, so you can calculate the t. So how we can calculate? So I will just rearrange the terms. So what I will do, I will take these things on this side. So what will happen? Minus half gt square will become plus half gt square, so plus ut will become minus ut, so minus h, right, as it is. So this is equal to 0. If you look at this equation, it is a quadratic equation in t. It is just like what? It is just like, say, half gt square minus ut minus h equals to 0. It is just like ax square plus bx plus c equals to 0. Okay. Quadratic in x, so here it is t square and t, quadratic in t. So what is the root of this equation? For this one, what you can write? X equals to minus b plus or minus root of b square minus 4ac divided by 2a. Okay. So same thing apply here. X equals to, so t equals to minus b. Here it is what? Minus u. So minus minus will become what? Plus. So minus of minus u plus or minus root of b square, that is u square minus 4. A is what? Half g. So a is what? 1 by 2 g. What is the c? C is minus h. So this is what? Minus h. So whole divided by 2a. 2 into a is what? 1 by 2 z. Okay. So now this 2 will get cancelled. 2 ones are 2 2s. Okay. So t equals to minus minus plus u plus or minus root of u square minus minus plus. So 2 4s are what? 8z. Okay. So are you getting? 4ac. Okay. So 8z divided by not only g, h will also come. Okay. 8gh. No, it is not 4, it is a h. So this will become what? 2gh. So divided by what? Divided by g. Okay. Sorry, I will take it as 4. So h it is. So 2gh divided by g. This is what the time. But time will not be negative, so no need to take plus or minus. So time taken to reach ground is what? T equals to u plus root of u square plus 2gh whole divided by g. Okay. This is what the final equation. You can calculate the time of flight, means total time taken to reach the ground when you projected it from a tower. Okay. So based on this one, there is one question in your NCERT book, page number 48 and example number 3.4. Page number 48, example number 48, and example is what? 3.4, I think. So 3.4 in your NCERT. Okay. In your NCERT book. Okay. So what they are saying? They are saying I am going for the B question. Now what they have given is, they have given u equals to 20 and then what they have given? They have given height h equals to 25. Okay. So in B question they are asking time. there are two questions actually, first question and second question. First question is what? How high will ball rise? Means this height they are asking. This you can calculate. That is what maximum height. You can take u as 20 and you can simply apply v equals to 0. So v square equals to u square plus 2as you can calculate. So for time you can apply this equation. So how you can apply this? So t equals to, what is u? U is 20 plus root of 20 square plus 2. G you can take it as 10. They are given in the question. So meter per second square. This is what meter per second. This is what meter. Okay, meter per second. So 2 into 10 into 25 divided by G. G is what? 10. Okay. So now what you can do? 20 plus or minus. This is what? Not plus or minus, plus. So 400 plus 2 into 25, 50. So this is what? 10. So what it will become? It will become some 500. Okay. So 500 divided by 10. So 20 plus root of 900 divided by 10. What is the root of 900? Root of 900 is what? 30. So 20 plus 30 divided by 10. So 50 divided by 10, you will get it as 4 seconds. Okay. So this is what the time. So what answer they got also is 5 seconds. Okay. So simply if you remember this one, you can calculate the what time. Or you may say we cannot remember all these things. Then very simple, we can go with this method. You can take h. So substitute here h equals to minus 25. I will do that also. So if you take h equals to minus 25 and u equals to 20, simply you can write minus h equals to ut plus half plus or minus half gt square. Okay. U is given, h is also given. So then gt square. You can just substitute the values. You can you will get it as instead of taking a minus h, you can simply take h. So if you substitute the h equals to minus 25, directly you can get here also. But it is better if you go through the standard formula also. However you are comfortable like that, you can calculate. Okay. Then apart from these things, what else they can ask? This is one parameter, time taken by body to reach the ground. What else they can ask? They may ask what is the maximum height it will reach. Okay, if you want to calculate this height, so what you have to do, you know the u value. So u is, you can take it as u. So v equals to what? Here v is what? It is going to be 0. So you can calculate this distance. Okay. So if this is say s1, then while coming back also s2, s1 and s2 are what? Same. Here they may ask what is the maximum height reached, that is s1. They may ask total distance traveled to come to the same point, that is s1 plus s2. Then they may ask total distance traveled, that is s1 plus s2 plus h. Okay. So like that they may ask anything. So we should be able to what? We should be able to calculate all those things. Okay. So if you want to know, so one more very important thing for your competitive exam purpose. Suppose there is a tower. Say its height is h. Okay. Say its height is h, and this is the ground. One person is standing over here. Okay. So one person is standing over here, another person is standing here. Okay. Both are throwing the ball. This person will drop on ball in downward direction. This person will throw a ball in upward direction. Okay. What velocity he will give? He will apply some velocity. So he will apply some force. So initial velocity is u. He has to throw with some velocity. He will simply drop it. So initial velocity is what? Initial velocity is going to be 0. Now they may ask when they will meet. Means after what time they will meet. They may ask when they will meet. Okay. So when they will meet, they maybe meet somewhere here. Okay. So this ball will come here and this ball will come over here. Okay, so say after time t they may meet. Before meeting, what they will do, it may not be different, right? It may not be equal. Okay, it may come here and this may be going till here. Okay, so this is what the distance, say if it covers say s1 distance. Suppose in this much time it will cover s1 distance and this will cover s2 distance. This is what the time. After time t they will reach. So how we can calculate that t? With the known quantities. What we know, you know u and h. Apart from that, nothing else. G you know. For this person, I will write the equation for S1. So what is that? S1 equals to ut. What is it? Is in downward direction. Downward direction means what you can write? Plus half gt square. Okay. So u equals to what? U equals to 0. If u equals to 0, so S1 is what? S1 is, this will become 0, half gt square. Okay, S1 is half gt square. Now, for this one, S2, for S2 what you can write? It is going in upward direction, but A is what? A is minus g. It is in downward direction for this one. So what you can write? ut minus half gt square. ut minus half gt square. Okay. So for upward motion, this is what S1 and this is what S2. S1, S2. See here, S1 plus S2 is equals to what? H, total height. So H equals to S1 plus S2. H equals to S1 plus S2. Now H equals to what is S1? S1 is half gt square. Half gt square. What is S2? S2 is ut minus half gt square. Okay. So what will happen? Half gt square minus half gt square will get cancelled. So h equals to what? H equals to u into t. So time t equals to what? H divided by u. H divided by u. When somebody drop ball from some height h and someone is throwing ball in upward direction, both will meet somewhere at what time? At a time of h by u. At a time of h by u, they will meet each other. H is what? Height. U is what? U is the initial velocity given to the body which is throwing upward. Okay. So this is what, when they will meet. They may ask where they will meet also. Where they will meet also. Okay. They may ask where they will meet. So where they will meet? They will meet at either S1 from the top or S2 from the base. Okay. So S1 is what? S1 is half gt square. If you don't know the t, you can calculate t and substitute there, or directly and substitute over here. Okay. So S1 equals to half g t. T is what? H by u. So h by u the square. So S1 is what? S1 is half gh square divided by u square. Okay, half gh square by u square. Okay, so where they will meet? They will meet at S1 from, they meet at S1 equals to half gh square by u square from top of the tower, from the top of our S1, from the base of the tower S2. So S2 is what? S2 you can calculate just like total is h minus S1. So h minus S1. So if you substitute the value of S1, you will get it as S2. So h minus half g h square divided by u. So you will get what? You will get S2. So they will meet at S2 equals to h minus S1 from what? From bottom or from the base of tower. From the base of tower. Okay. So they may ask anything. They may ask where they will meet from the top of tower. They may ask where they will meet from the bottom of tower, or they may ask at what time they will meet. So better if you calculate at what time they will meet, even though they ask that one. Okay, if you calculate time directly, you can substitute that value over here, you will get the S1. So if you know the S1, you can easily calculate the S2. Okay, so this is what how we can calculate the time when they will meet and where they will meet. So that is what all about the motion parameters. So when we solve the problems, you will come to know, you will understand better way, or you try to solve the problems by taking your own values of u, v, whatever. So a little practice it. It is very much helpful for your competitive exams. Of course, not much important for your theory. Okay. So now one more very important concept for as your board exam is concerned. That is what the Galileo's law of odd numbers. Sometimes they will ask for 3 marks to define Galileo's law of odd numbers or explain Galileo's law of odd numbers. Okay. So what it is, what Galileo said about the odd numbers. He did not tell about the odd numbers. He did not give about the odd numbers. So he was given the distance traveled by an object which is under free fall. Okay. Suppose object is at rest here. Okay. If we make it to fall down, what will happen? Here it is u equals to 0. Okay. No need to worry about that one. When you drop it, what will happen? Its velocity go on increasing. When it reaches the ground, it will be what having the high velocity. Okay. So velocity is increasing means distance traveled in per second is also increasing. Okay. In 1 second it may come over here. In 2 seconds it may come over here. In 3 seconds it may come over here. Okay. So these are your distances varying. Distances are varying. Okay. Why distances are varying? Distances are varying because velocity is increasing. Okay. So this is what in 1 second it will come over here. In 1 second, in 2 seconds it will come here. In 3 seconds it will come here. Okay. What Galileo is saying, distances traveled in 1 second. Here also what 1 second. Here also 1 second. Distances traveled in equal intervals of time is same as ratio of odd numbers starting from unity. Okay, now you will understand after getting the values. Okay, now here this is what distance traveled S1. Okay, here how we can get it S1. What is this distance? This distance is saying this distance S1 is S1. You can write ut plus half plus or minus plus half gt square. Okay, so initial velocity is what 0, so no need to write ut. So what is the distance traveled? Distance traveled is what half gt square. Okay, so distance traveled is half gt square. Okay, next here S2, distance traveled in 2 seconds. This is what distance traveled in 1 second. So substitute t equals to 1 also here. Half g 1 to the square, that is what half z. Okay, now distance traveled in 2 seconds, this distance. Okay, so this distance is what half g to the square. So this is what 2 to the square is 4. So I will write half g as it is, half z. So distance traveled in 3rd second. So S3 is equals to half g 3 to the square, t equals to 3 seconds. Okay, so 3 to the square, what you can write? 3 to the square is what 9. 9 I will take outside. So this I will write as it is, half z. Okay. So these are the what distances traveled in 1 second, 2 second, 3 second. Now, what is the distance traveled in this 1 second? Distance traveled in 1 second is, here it is 0, here it is half g. Half g minus 0 will give you what? Distance traveled in 1st second. That is what t1 is what? Half z. Okay. Now, what is distance traveled in 2nd second? Only from here to here I want. How we can calculate? This total minus this. This is what? This total. Okay. From here to here it is S2. From here to here it is what? S1. What do you want? You want this. So how you can calculate? S2 minus S1 will give you what? Distance traveled in 2nd second. Okay. So how we can calculate S2 minus S1? So distance traveled in second is S2 minus S1. So what is S2? S2 is 4 into half g minus S1 is what? S1 is half g. Half g. Okay. So take half g constant. 4 minus 1 is what? 3. So what you can write? You can write as 3 into half g. Okay. Half g is what? Constant. This is what distance traveled in next second. Again in 1 second. This is what distance traveled in first 1 second. This is what distance traveled in next 1 second. I want distance traveled in again next 1 second. Okay. How can you calculate this one? This total is what? S3. S3 minus S2 will give you what? This distance. Okay. So distance traveled in third second is what? S3 minus S2. Okay. What is S3? 9 half z minus 4 half z. 4 half z. Okay. Half g is constant. You take it outside. So 9 minus 4 is what? 5. Okay. So 5 half g, this is what the distance traveled in 1 second here after 2 seconds. Okay. So these are the what? Distance traveled in first second, distance traveled in second, distance traveled in third second. Okay. This is different. This is what distance traveled in 2 seconds. I don't want distance traveled in 2 seconds. I want distance traveled in second. So this is what is distance traveled in second. So in third second, 5 half g. Okay. So this 1 second, this 1 second, this 1 second, all are having the equal interval of time, 1 second. But distances traveled are not same. Distances traveled are different. Okay. Time intervals are same, 1 second, 1 second, 1 second. Because its velocity is changing, so distances traveled in those 1 seconds are different. This is what Galileo concentrated. Distances traveled in equal interval of time is not same. Then how it is varying? It is varying in the ratio of odd numbers. So if you take the ratio of ST1, ST2, ST3. So what is the ST1? It is half g. So half g. So ratio. So this is what? 3 half g. 3 half z. Next 5 half z. 5 half z. Okay. So half g are the what? Constant. So no need to worry about this one. Here what it is? 1 is to 3 is to 5. Okay. So ST1, ST2, ST3 is equals to 1 is to 3 is to 5. If you take next ST4, that will become what? 7. If you take ST5, that will become what? 9. Like that. Okay. So ratios are what? Ratios are in the odd numbers. Okay. So distances traveled, ratio of distances traveled in equal interval of time is what? It is the ratio of odd numbers. This is only what Galileo suggested. Okay. If they tell distance traveled in first second is 10, what is distance traveled in next second? It will be 30. What is distance traveled in next third second? It will be 50. Getting the point? If suppose distance traveled in first second is 3, what is the distance traveled in second? Distance traveled in second is what? 9. What is distance traveled in third second? It will be 15. Why I am taking 3, 9, 15? If you cancel it, so what will happen? 3 1s are 3, 3s are 3, 5s are. So again ratio will come what? Ratio will come 1 is to 3 is to 5. If distance traveled in first second is 20, what is the distance traveled in next second? 60. What is distance traveled in next second? It will be what? 100. So 1 is to 3 is to 5. So 1 is to 3 is to 5. This is what Galileo concentrated. Distances covered by freely falling body in equal interval of time stands in the ratio as the odd numbers starting from 1 or unity. Okay. So that is what the definition he has given. So what I can write the definition of this Galileo's law of odd numbers. So Galileo's law of odd numbers suggested the distances covered or the distance covered in equal intervals of time, equal intervals of time by a uh, body falling freely, from rest stands and one another in the ratio same as in the same ratio as the odd numbers, beginning from unity. Definition maybe seems to be a little complicated, but simple. The distance is covered in equal interval of time by a freely falling body from rest is in the ratio of 1:3:5, like that also you can write, or in the ratio of odd numbers beginning from or starting from what? Unity. Okay, so you can make your own definition, no need to follow this one. So if you want your textbook definition, it is there your page number 50, example number 3.6. For definition you can go with page number 50, example number 3.6. Okay, so it is there your NCERT book. So from there you can get the definition, or you can frame your own definition. Okay, what is that? In equal interval of time, the distance is covered by freely falling body from the rest is in the ratio of what? In the ratio of odd numbers starting from 1 or starting from unity. Okay, so this is what the Galileo's law of odd numbers, very important for your theory exam.